guys. Well, it's much more fun with Miss Rogers around, but we're going to do what we can because she is not here today. I didn't want you to fall behind. So you've already watched the video on Nana's chocolate milk, and hopefully you understood why having equivalent ratios is so important. Another word for equivalent ratios is a proportion, and we are going to look at proportions today and how we can solve for a missing part in a proportion. Before we do that, though, we want to know, how do you know that ratios are equivalent? To do that, you check the cross products, and we know that product has to do with multiplication, so we're going to check the cross products with a couple ratios. If we have a ratio of 4 to 5, and we're comparing it to a ratio of 6 to 7.5, what we do is we cross multiply going diagonally from bottom to top, and we kind of make a little pretzel type shape, and we multiply 5 times 6 is 30, and then we would multiply 7.5 times 4, and maybe you don't know that off the top of your head, so we're going to multiply it out here. 7.5 times 4, and that indeed gives us 30. So yes, these are equivalent ratios. Let's try a couple more to see if we have equivalent ratios or not. We'll move down a little bit. If we look at our two ratios, 9 to 5 is equal to 36 to 20. We want to see if they really are indeed equal. So we're going to do our cross product method, little pretzel method, and we're going to multiply 36 times 5. So I'm going to over to the side do that. 36 times 5 is 180. And then 20 times 9, I can do that in my head, and that equals 180 also. So these are equivalent. Yes, they are. Let's try another one. 12 times 3 is 36. 10 times 4 is 40. So these guys are not equivalent. So this is a big nope. They are not equivalent. How about you do the third one on your own and see what you get, and then you can look at the next video.